Hi, this is Dr. M. Gangappa, Department of AIML. Today I am going to discuss one important topic in Automata and Compiler Design. Topic name is First and Follow Function Computation. So this is one of the important topic for construction of the parsers like top-down parser and bottom-up parser. Today's session is very important. Let us go to see how to compute it. So first function and follow function. First and follow functions are functions that are used to find the terminal symbols that are required to verify the terminal in the sentence. Right? So first and follow functions gives us a set of terminal symbols. First function gives us the first terminal symbol in the grammar, and follow function gives us the terminal symbol that follows the non-terminal. So let us see one by one. So this is first and follow functions are required so that parser can parse properly, apply the needed production rule at the correct position. This is the one of the concept, right? So definition of the first function. This is the definition. First of alpha is a set of terminal symbols that begin the strings derived from alpha. Here alpha is a grammar symbol. So first function gives us the first terminal symbol. We should remember one thing, that first function gives us the first terminal symbol. Let us see how to compute the first function by going through some rules, and after that by observing some examples. So rules to compute the first function. First rule is, suppose x is a terminal symbol, then first of terminal is terminal, because first function aim is to compute the first terminal. So if it is x is a terminal, then the answer for the first of x is x only, because x is a terminal. So this is the first rule. Now second rule is, suppose x derives epsilon is a production, then first of x gives us the epsilon, because x can be replaced with the epsilon. Here epsilon becomes one terminal, therefore first of x gives us epsilon. Now third rule is very important rule. This rule is applicable for the non-terminals, whereas first two rules, rule 1 and rule 2, are applicable for the terminal symbols. Now we are going to see how to apply the rule for the non-terminals. Suppose the production rule is x gives y1, y2 and so on yk. So here y1, y2, yk are the symbols in the RHS of the production, and y1, y2, yk are all non-terminals. In such case, how to compute the first function for the symbol capital X? Let us see one by one. So here rule for this one is 3.1. I am writing, if y1 doesn't derive epsilon, y1 doesn't derive epsilon, then first of capital X equal to first of y1 minus epsilon. This is the rule to compute the first of x when y1 is a non-terminal and y1 doesn't derive epsilon, right? Means in any case y1 shouldn't be epsilon, y1 shouldn't be replaced with epsilon. For suppose y1 is deriving epsilon, in some cases, in such case we can compute first of x as first of y1 minus epsilon union first of y2. Means whenever y1 derives the epsilon, in such case y1 disappears here. So whenever y1 is disappearing, in that case we should go to take the next symbol that follows the y1, that is y2. So for that symbol we should compute first. So that is the This is the rule how to compute first of x when y1 is deriving epsilon. Now similarly, now here I am going to take one more case. If y1 and y2 both are deriving epsilons, then first of x can be computed as first of y1 minus epsilon union first of y2 minus epsilon union first of y3, because first two terms y1 and y2 are deriving epsilon. In such case we should go to apply the first function for the next symbol, that is y3, right? Similarly, suppose nth case, last case, suppose y1 y2 and so on yk are all deriving epsilon. In such case, how can we compute first? First can be computed by using the formula I am writing here. First of x equal to first of y1 minus epsilon union first of y2 minus epsilon union first of y3 minus epsilon union and so on first of yk minus epsilon union epsilon, because here y1 y2 and so on up to yk symbols are deriving epsilon. When we replace epsilon for all that symbols, then finally we get the answer is epsilon. Therefore we should add epsilon as well. This is the final rule. So these are the three important rules and sub rules to compute the first function, right? If we remember all of them clearly, then we can solve the problems one by one. Let us see how to apply these rules by taking one example. So these are all some of the examples. Here I am going to take one example. After that we'll see one by one. Example for the first one is, suppose here I am taking one grammar. Context free grammar. A derives A is a grammar production. Suppose we are asked to find the first of A. In that case, first of A. What is the answer for the first of A? What is first of A? First of A. What is first of A? So first of A means, by using the rule 2, by rule 2, here A can be replaced by small a. So first of A gives us small a only. Small a. First terminal. So in the RHS, we have a first terminal small a. So similarly, we will go to one more example, one more grammar. Example 2. Example 1. Example 2. Here is A gives AB or BC, small c. B gives D. So this is an example. Compute the first. Compute first of A. First of A. How can we compute? Let us see. To compute first of A, what should we do here is, we should go to first of A. Solution to that is, first of A. First of capital A. First of capital A can be computed by using the rules 1 and 2. Rules 1 and 2. So by using the production, A gives AB. If we apply the first for this, then what we get? Here first function will go to see the first terminal in the RHS. So there is a first terminal in the RHS. Therefore, the answer for this one is small a. Answer for this is a first terminal. Therefore, answer for the first case is A, union first of B. By using the first of B, because A gives BC. Next production for A gives BC. Here we should apply the rule 1 minute. Rule by rule 3(1), because in the RHS B is a non-terminal. So first we observe whether B is deriving epsilon or not. B doesn't derive epsilon. So whenever B doesn't derive epsilon, in such case we should go to the rule 3(1). So by using the rule 3(1), we can compute the first of B. So what is first of B? First of B can be computed as first of B. First of B can be computed by using the production B gives D. So in this production, we can compute the first of B. So when we replace B by D, then first of B can include D. Answer is D. So B can be replaced by D. Therefore, here D is a terminal. First of terminal is terminal. Therefore, answer is, what is the answer? This is A union. This is D. So final answer is A and D. A and D. So this is how you can compute first function by using the rule 1 and 2. Right? Shall we go to one more example so that we can easily understand other rules as well. Let us take one example. So let us go to the first example, first problem, that is S gives A, B, C, D, E, A, B, C, D, E, and A gives B R epsilon, B gives C R epsilon, C gives D, D gives E R epsilon, E gives G R epsilon. So let us consider this example and let us solve how the first for this grammar. First for this grammar. To compute first for this grammar, so what should we do here is, let us see this. First of S, first of capital S can be computed by using the rule 3 2, because let us observe here. In order to apply which rule is perfectly worked out. So let us observe. So here S gives here the production is S gives A, B, C, D, E. In this case, here A is deriving epsilon, B is also deriving epsilon, but C doesn't derive epsilon. Therefore, what should we do? We should apply rule, which rule? Y1 and Y2 both are epsilons. So 3 2, 3 3 by 3 3 rule, by 3 3 rule. So this is 3 3 by 3 3 rule. We can compute first of S. So how can we compare this? By 3 3 rule. So first of A minus epsilon union. Okay. First of B minus epsilon union first of C, right? So let us see how to compute first of B. First of B, let us compute the first of B here. First of B, to compute first of A, not B, first of A, let us take the production A gives B or epsilon. This is the production to compute the first of A. So in this production, observe the alternatives. This is the first alternative, this is the second alternative. In the first alternative, A can be replaced by B. So what is the first terminal in the RHS? B is the first terminal. So first of A includes B, 1 for the first alternative. Come to the second alternative. In the second alternative, A can be replaced by epsilon. So epsilon is a terminal symbol, therefore first of terminal is terminal. So final answer is B or epsilon. This is the answer for this. Answer for that is B comma epsilon. B comma epsilon minus epsilon. Is it right? Union. Similarly, first of B. So to compute first of B, we should take one more production. That production is, I am writing here. To compute that, the production is B gives C or epsilon. This is the production. By this production, we can compute first of B. First of B can include C or epsilon, because in the in this production, B can be replaced by C. C is a terminal, and B can be replaced by epsilon. Epsilon is a terminal. So by rule 2, we can get the answer as C and epsilon. So answer is C comma epsilon. So for this, C comma epsilon minus epsilon. Union, I am clearing this. First of C. First of C can directly include D, because in the RHS of the first of in the RHS of the production, C gives D. D is a terminal. So answer is D. So let us see this. C gives D. So C is here in the RHS. This is the first terminal is. This is the first terminal. Remember this. First terminal. First terminal is D. Therefore answer is D. So let us compute the first for this. It is for this first. So epsilon gone. Epsilon gone. Epsilon gone. Epsilon gone. So remaining answers are B union C union D. So final answer is B comma C comma D is the final answer for this. So first of S can include B, C, D. B, C, D. So next one is let us compute first of A. Already we have computed. Once again, let us see first of A. First of A can include A, B or epsilon. B or epsilon. Similarly, first of B can include C comma epsilon, because C is a first terminal and epsilon is the terminal symbol, and first of C can include only one first terminal in the RHS, that is D. That is D. And first of D can include, first of capital D can include the first terminal symbol E comma epsilon, and similarly first of E can include G comma F, because G is the first terminal for the first alternative for E production, and F is the terminal symbol, first terminal symbol for the E production for the second alternative. Therefore, G and F are the two terminals for the first of capital E. So this is how you can compute the first for the first grammar. So similarly, we can go to the second grammar as well. Let us see the second grammar. S gives B, capital B, small b, capital C, small d. Let us take the second example. Example 2. Grammar 2. S gives capital B, small b, or capital C, small d. Next one is B gives AB or epsilon. B gives AB or epsilon. AB or epsilon, C gives CC or epsilon. C gives capital C, small c, CC or epsilon, CC or epsilon. So let us say how to compute first of S. So to compute first of S can include first of B. Here B is deriving epsilon, therefore we should remove epsilon, and then we should go to apply the first for the next symbol, that is first of B as well, because B is deriving epsilon. In this S gives B case, B is deriving epsilon, therefore we should apply first for this as well as first for next symbol. This is how we can compute, right? And the next one is for the production S gives BB. We have written the formula like this. And next, for the next alternative for S gives C, capital C, small d. How can we write the first? So this is the second alternative. Therefore, here I am using 1 minute. I am using union operation. S gives for BB. This is computed. Now we are going to compute the first for the next alternative, that is CD. For CD, now we are going to compute it. First of capital C, because C is a non-terminal. So immediately what should we do? We should go to apply the which one? Okay, pen minus epsilon, and here C is also deriving epsilon, therefore we should apply the first for the next symbol, that is first of D. First of D as well. Now let us see. First of B can be computed by using the production B gives AB. In this production, we can compute the first of B. So for this B, the first terminal in the RHS is A. Therefore, answer is A. Answer is A. And union. And for the next alternative for the B is epsilon. First of epsilon is epsilon minus epsilon. Union. First of B is B. Union. First of C is C comma epsilon. I am writing quickly. And minus, 1 minute, minus epsilon. Union. First of D is D. First of D is D. Now let us see. Let us observe the values. So here epsilon and epsilon both are cancelled. Here epsilon and epsilon both are cancelled. Next one is remaining symbols are A union, B union, C union, D. Union D. So final answer is A, B, C, D is the answer for the first of S. Similarly, it is quite easy to compute first of B. First of B is A comma epsilon, because for the B production, the alternatives are B gives AB. This is the first alternative. B gives epsilon. This is the second alternative. In the first alternative, the first terminal symbol is small a. Therefore, the answer is A. And in the second alternative for the B production is epsilon. Therefore, answer is epsilon. Right? Like this, we can find out the first for B as well. Now, let us see how to compute the first for next symbol is first of capital C. First of capital C, to compute first of capital C, we should take the production C production, that is first of capital C goes to C or capital C or epsilon, right? So in the first alternative for this productions small c, therefore first terminal is terminal, and second alternative there is an epsilon. The first of epsilon is epsilon. So this is how we can compute first for this. So these are the two important examples I have explained how to compute first function. Now let us go to the follow function. Follow function, already I told you that the follow function is also one of the important function in the construction of the parsers, mainly in the predictive parser or LL1 parser, or similarly like bottom-up parsers like SLR parser and some other parsers as well. So here, what is the main concept of follow function? So when we observe the follow, we can easily understand that where do we apply the follow function? Follow. So what is the meaning of follow? Follow is a function that gives us the terminal that follows the non-terminal, immediate non-terminal. Simple example I am providing you here to understand the concept. The example is, suppose A gives b small a. Here in the RHS of this production, A gives b small a, capital B small a. Here A is a terminal that immediately follows the non-terminal capital B. Therefore, follow of capital B equal to small a. This is the concept of follow function. I hope you could understand this. And similarly, here we are going to see the some of the formulas by which we can compute the follow function clearly for the grammar, right? So first rule to compute the follow function is, first rule, let us see. First rule is we should place the dollar sign in the follow of capital S, where S is the start symbol of the grammar. S should be the start symbol of the grammar. Whenever the symbol is a start symbol of the grammar, in that case we should place the dollar sign in its follow function. And second rule is, this is very important rule. A gives alpha, B beta is a production, and beta, here when we observe the beta is not deriving, and beta is not deriving epsilon. This is very important to remember, is not deriving epsilon. In such case, we can directly compute first of beta minus epsilon for the follow of B. So we can write follow of B as follow of B. Suppose what follows this B, capital B. Let us take simple one. I'll clear this. So suppose you want to know what follows follow of capital B, means first of beta minus epsilon. This is the rule to compute follow of capital B. Means we can easily understand who follows capital B by using the follow function, right? Similarly, suppose beta, here beta is not epsilon, beta is not epsilon. In that case, we can go to that. In some cases, beta, here beta after B, after capital B, may be epsilon. In such case, what should we do here is, so this B follows capital A only. B follows capital A only. This is the answer. Follow of B includes, we can write like this, follow of B can include follow of A. This is the one more rule. So these are the three important rules to remember to compute the follow function. Let us go to find the follow function for one grammar. Here I am considering one grammar. E gives T E dash, E dash gives plus T E dash, T gives F T dash, T dash gives star F T dash or epsilon, F gives open parenthesis capital E or close parenthesis or small id. So to compute the follow function, what should we do here is, first we need to know the first for all the symbols, grammar symbols of that grammar. So therefore, let us compute the answer is compute first and follow. So let us compute the first of capital E equal to, so to compute the first of capital E, what should we do here is, we should take the production E gives T dash. In that E gives T dash, when we observe the right side, the first symbol is non-terminal. So here we should go to the third rule. In that third rule, here we should observe whether T derives epsilon or not. In this grammar, T doesn't derive epsilon. Therefore, we should apply the 3-1. So by using the 3-1, what should we do? First of E equal to first of T only. T minus epsilon, we get only the T, no problem. And next one is, let us go to the T production. First of T goes to ft dash. So here F, let us observe the F is also not deriving epsilon. In that case, first of F is also computed like this. So first of F. So in that first of F, we should observe the alternatives. So in the first alternative, there is a first terminal symbol, that is open parenthesis, and the second alternative, there is one terminal symbol, that is ID. Therefore, answer for first of E, first of T, first of F is open parenthesis and ID. Similarly, first of EDS, first of, here I am writing clearly, first of F, first of EDS, first of T dash. Here I am clearing. I'm going to erase this. Open parenthesis ID. For this open parenthesis ID, for this open parenthesis ID, for this plus comma epsilon, from the production EDS gives plus T EDS or epsilon. So first terminal in the first alternative is plus, and first terminal in the second alternative for EDS production is epsilon. Similarly, T dash production. What are the terminal symbols for the T dash production? T dash production, first terminal is star, similarly epsilon. This is how we can compute the first function for the grammar. So after computing the first, then we should compute the follow. We should compute the follow. To compute follow, so we should take the follow for the all the grammar symbols. Here I am taking the grammar all non-terminals. What are the non-terminals we have? First of all, let us understand the non-terminals. What are the non-terminals in the grammar? So first, let us understand the non-terminals. What are the non-terminals? Non-terminals are E, E dash, T, T dash, and F. For all these non-terminals, we should apply the follow function. So let us go with the first non-terminal, that is E. So here I am taking follow of. We should apply follow function for all the non-terminals. Here I am taking the first non-terminal, that is E. First of E. To compute first of E, we should go to the rules one by one. So what terminal symbol that follows the capital E? To know that, we should apply the rules one by one. So here let us observe the first rule. What is the first rule? Place the $sign if the symbol is the start symbol of the grammar. So let us observe whether E is a start symbol or not. So E is a start symbol. Therefore, what should we do? We should apply we should add $sign to the follow of capital E. So to compute follow of capital E, we should take the appropriate production to compute it. So which production is right production to compute the follow of E? Means E should be in the RHS of the production. So in which production E is in its RHS? In the first production. So in the first production, there is no E in the RHS. In the second production, there is no E in the RHS. Third production, fourth production, fifth production, there is E in the RHS. So let us go with this. F gives open parenthesis, capital E, close parenthesis. So here E is in the RHS. So who follows this E? Who follows this E? Only the terminal, that is close parenthesis. The answer for this is this. This is the answer. So any more production that have E in its right side? No more production. Therefore, we can close this. And similarly, we should compare the follow for EDS. Follow for EDS. To compute follow for EDS, let us observe the EDS symbol. Whether EDS symbol is the first start symbol or not. Here EDS is not the start symbol of the grammar. Therefore, we cannot apply the first rule. So instead of first rule, we can go to apply the second rule or third rule. So let us see which rule is applicable to compute the follow of EDS. So in order to apply the rules 2 and 3, what should we do here is we need to take the symbol EDS in its right side of the production. Right side of the production. So which production that contains EDS in its right side? So obviously first production. Yes, first production E gives T EDS. In this case, EDS is in its RHS. So this can be treated as capital B, this is alpha and this is A. According to our rule, A gives alpha B. This is the rule. When we compare this production, E gives T dash with the rule 2 or 3. So this is quite similar to A gives alpha B, right? So this is rule 3. This is obtained by using the rule 3. By using the rule 3, what we get here? Follow of B includes, follow of B can include follow of E. So follow of B can include follow of E. Similarly, according to this, follow of E dash. Why? Because B is quite similar to E dash and A is quite similar to E. So follow of E dash can include follow of capital E. Therefore, answer for this is follow of capital E. So what symbols are in the capital E? So that is dollar sign is one symbol. Next symbol is close parenthesis. So these are the two symbols, right? Like this we can compute. Very easy to compute this, right? Next one is follow of T. Follow of capital T. To compute follow of capital T, we should take the appropriate production. So it is the first production in which T is in its RHS. So let us take E gives T dash. So first observe this as capital B, and alpha is there is nothing before B, therefore alpha is empty, and beta is epsilon. Beta, and this is E. So here beta is deriving epsilon, right? Beta is deriving epsilon. Deriving epsilon means what rule is applicable? So we can apply the rule. Rule 2. By rule 2, what we get here? By rule 2, we can get the answer is follow of E dash can include, follow of T can include, we can write like this, follow of T can include first of E dash minus epsilon union. Because this is deriving epsilon, what should we do here is we should apply the follow of E as well. From this follow of E dash, first of E dash already we have computed earlier. So the answer for that is plus comma epsilon minus epsilon union follow of E. Follow of E already computed. I am taking that answer, that symbols dollar and close parenthesis. So final answer is plus close parenthesis and dollar. So final answer is plus close parenthesis and dollar. This is the answer for this. Similarly, let us compute the follow of T dash. To compute follow of T dash, we should take the appropriate production. What is the appropriate production to compute follow of T dash? So T dash should be in its RHS. So let us take the production where T dash is in its RHS. So obviously you can go to the third rule, third production. So what is the third production? Third production is T gives F T dash. Here T dash is in the RHS. So this is capital B and this is A. Sorry, this is alpha and this is A. So which rule is applicable? So by rule 3. By rule 3, because beta is not appearing. Therefore, by rule 3, what we get? Follow of T dash can include follow of T. T dash can include follow of T. Follow of T. So follow of T dash can include follow of T. What are the symbols in the follow of T? We can take the same symbols in the follow of T dash. Right? This is how we can compute follow of T dash. Now let us go to compute follow of F. Last one is follow of F. To compute follow of F, we should take the production where F is in its RHS. So first production has no F in its RHS. Second production has no F in its RHS. Similarly, third production, there is a F in its RHS. So we can take the third production. So T gives FT dash. T gives FT dash. So this is the production, useful production to compute the follow of F. So from this production, we can compare this production with the rules. This is A, capital A, and this is capital B, and this is beta. Here T dash is deriving epsilon, therefore we can apply the rule that is follow of f can include first of t dash minus epsilon union follow of f, follow of t, follow of t, follow of t. So from this first of t dash, what are the symbols we have in the first of t dash? First of t dash contains some symbols, star comma epsilon minus epsilon, right? Union fall of t, this is for t, fall of t, fall of t already computed. I am taking these symbols from the computed answer, plus comma close parenthesis and dollar. So what is our answer? Answer is star plus close parenthesis and dollar. So star is one symbol, star on symbol, close parenthesis, plus and a dollar. So this is the answer for this. This is how we can compute the follow for the grammar. To compute the follow, remember one thing, that we must compute the first as well. So from the first we can compute follow also. And first and follow are the two important functions that are useful in the construction of the top-down parser as well as bottom-up parser, right? Thank you one and all for watching my video.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.